Yeah.
Yep.
Yeah, let's get to
Yep.
it.
Yeah. All right. So, oh, there's still a few people coming in. Are you admitting them, Putra? Yep. All good.
Yeah.
Welcome everyone to the ioGAS 8.1 release webinar. As usual, Putra is going to take you through the new features and explain the new additions to the software. Of course, the last release, version 8, was the big release, V8 as we called it, which brought in the automated workflows, etc. This one being a .1 is an incremental improvement on that, but still very significant. As usual, we will keep our eyes on the Q&A window while Putra is chatting. So if you have some questions along the way, just put them in, and either Sophie or I will respond to them in the chat window. There'll be a spot at the end of the webinar as well, if you'd ask some questions by voice, if you like. And right at the end, I'll just talk about a couple of speculative things that we're working on, which if you're interested in those, and then by all means you can contact us after the webinar to talk about them separately. So without further ado, I'm going to hand over to Putra now, because he's the expert, and he's going to take you through the new features of 8.1.
Thank you, Dave. Yeah, let's get cracking. So 8.1 is an incremental release. As Dave said, version 8 was the big one that we released in December last year. So it has only been about 7 to 8 months since we last did this. So it hasn't been that long, but 8.1 being an incremental release really serves to improve some of the things that we introduced in version 8. And a part of this is in basically fleshing out the workflow recorder tool in ioGAS. So when we introduced the workflow recorder, there were a number of tools that we didn't have support for those when we released it in version 8. And as a part of that, we have added support for provided workflows. So if you're familiar with the concept of provided diagrams and calculations and spider plot, we have actually added the ability to supply you with workflows from within the program. And I'll show you through the demo of how this will look like. So the way that we will run our presentation today is we're going to run through this slide deck, and then we'll run through a demo of ioGAS afterwards. So a part of some of the bigger improvements that we have in version 8.1 is the overhaul that we have added to the mineral and rock nodes dialog. So if you have used the mineral and rock nodes tool before, you know that it's been around in ioGAS for a long time. And over the years, we have improved it. But 8.1 is the release that we've actually overhauled the way that we can select and configure that our selection in this dialog. And for now, you're able to actually save your selection in the mineral and rock nodes dialog, and we'll show you how it works in a bit. A large number of work that we've done in 8.1 is a lot of things that you don't see in the front, when you're using ioGAS. So a lot of this has to do with under the hood kind of thing. So some of this engineering work includes speed improvements, enhancements to the Mac version of ioGAS. So if you're using ioGAS on the Mac, I don't know if any of you here in the chat uses ioGAS on the Mac, but we've added support to allow you to import larger data set, whereas previously you couldn't do that. You can only do that in the PC version of ioGAS. We've also added a backend support for new licensing, and I'm going to show you this in the demo. So just for a bit of an explanation, so you don't get too confused when you start using ioGAS 8.1. And we've also added support for a new API, which Dave and I will talk about briefly at the end of our presentation. But again, that's another example of one thing that you couldn't see out in the front when you're using ioGAS. So it's another under the hood kind of thing. A bunch of other enhancements. You can see it on the list on the screen, but we'll be able to walk through it as we go through the live demo. So with the workflow recorder, a number of features that we are now supporting with the workflow recorder. And a part of this is the things that you can do on the right-click plot menu option. So exporting image out of a plot. Some of the things that you do in the right-hand side toolbar can now be recorded in a workflow recorder. So we'll show you how you can record a workflow for example, to activate a selection of mineral and rock nodes. That's an example that we'll run through in the demo. We've added support for regression analysis through the workflow recorder. That's one thing that people have asked a couple of times since we released version 8. The first thing they ask us is, where's the support for regression analysis recording? So yeah, so we have now added that in 8.1. So a bunch of things here that you'll be able to see on the screen, but we'll run through this in the demo as well. So this is a big part of 8.1, and this is the provided workflows. So if you're familiar with the concept of provided calculations, diagrams, spider plot, things like that, this is an example of this. So we have shipped a couple of basic workflows that works with our demo dataset. So if you've used ioGAS to look at our demonstration data, you have some workflows that works with some of these files. And one of these is what we'll show in the demo. So that's a combined analytics workflow where you combine the result of PCA and UMAP and DB scan as an example of a recorded workflow. We've also added some rock classification workflow just based on things that people commonly use in the industry. So it's a slim selection at the moment, so we only have 3. But the idea is that as we receive more feedback from our users, so yourself, you can let us know what sort of workflow would you like to see in ioGAS, and we can add them in. So I'll show you an example of something that's inspired by Scott Haley's workflow. Perhaps some of you have looked at his tutorials on his website. So we've created a porphyry copper geochemistry workflow just for rock classification. And we'll be able to run through this in ioGAS. And another workflow that we include is the barcode project workflow, which is the workflow that we actually showed when we did the ioGAS version 8 webinar. So we've actually included that as a provided workflow in 8.1 now. So the mineral, yes, Dave.
Yeah, for the academic people or the people from universities that are listening to this live or as a recording, if you can think of really good teaching workflows or workflows that would help you run courses and classes, then we'd be more than happy to add them into the shipped version of GAS. In fact, we would love to do that. So please, any ideas you have, we're all ears.
And with the mineral and rock nodes dialog, we'll run through this in the demo, but you can see here that it's basically, it has been overhauled, but the main idea is it allows people to save and load user node selections. And you can share this with other users within your company as well. And there's a bunch of GUI improvements that makes it easier for you to, for example, select multiple nodes at the same time, and to be able to record the selection of nodes in a recorded workflow. So this is another exciting thing that we've added in 8.1. So as part of our suite of performance optimization, so we've added a new rendering mode in ioGAS that is possible to make it faster to visualize your data in a scatter plot or a ternary plot or a scatter or XY diagram or a ternary diagram. Basically what it does is if you have a bunch of data points on top of one another, this new render mode basically obfuscates the data points underneath that points on top of each other. And we'll show you this in a bit, but it basically results in a faster rendering speed, which makes a huge difference if you're running a big file. So this is one thing that we'd like people's feedback on, and you'll be able to see it. It makes more sense once I show you through this. So this is another one that is quite important. So it's the aliasing exceptions configuration file. So basically what this is if you use ioGAS in the past and if you have, for example, columns from a spectral mineralogy result, so perhaps something from Osiris or a petrophysics column or a log geology column, and then if you click on the guess alias button, you know that it sometimes accidentally alias a rock type column as an assay column. Well, you can set up a list now to basically exclude them from being aliased as a geochem column. So so if you have columns for mineralogy, for example, you can choose to exclude them. So ioGAS doesn't think that CPX is alias as something like copper or something like that. So yeah, so it's another useful thing that you can configure on your end on your own. Yes. Another one is again 8.1 being an incremental release. We have improved the way that we've done the tool search in ioGAS. So so we've added this feature in version 8, the tool search function. But now that with this, we are now able to filter it by tool type. So say if you want to only look for provided resources for basalt that has to do with it being a spider plot or a diagram, you can select the type of tool in here. So you can filter by tool type and whether they are user created or provided by us within ioGAS. So it just makes the search function a bit easier to use. And if you haven't used it before, because we introduced it in V8, you should use it because it's quite useful, especially now that we have so many tools in ioGAS. The missing data analysis. This is something that has come up, before in training, in ioGAS training that we have done over the past year. What we've realized is that when people want to use the missing data analysis, and I hope you're using this tool, but in the missing data analysis, you essentially only want to select the variables that are not missing certain elements. So basically what you want is, rather than selecting these variables manually from this list, you can just right click on the missing data patterns and choose it to replace existing variable selection instead of doing it manually one at a time, which is quite neat. And it's much faster than looking at this list and just taking out the elements that are missing values. So if you have used the query select tool in ioGAS, you know that we have added this in the data window in version 8. So it was a bit hidden. So we admit that it's a bit hard to find, but now we have actually moved it under the data menu. So this is quite a neat little tool. And I'll just show you a quick demo of this once we run through that session. But it basically means that you can access this tool without having to open the data window. So if you have attended our version 8 webinar, I'll just give you a refresher on this. It's basically you can search rows by certain criteria. So for example, if you want to search, find me all rows that have silica higher than 58% and logged as granite or quartzite, things like that. So you can build that kind of query using the query select tool. And before it was in the data tool, so it was a bit hard to find, but now it's in the ribbon, so you can just get to it a bit quicker. A bunch of other enhancements and improvements. I'll talk a bit about that higher RAM executable to the Mac OS installer. And there's a few other things in here that we'll add to the demo as well. So yes, so we have a couple of slides here that Dave will want to run through. So take it away, Dave.
Yeah, so this is one of the things which is hidden, if you like, in GAS. So we have taken GAS and wrapped it in an API, an application programming interface. What that's allowing us to do, though, is run GAS unattended. Informally, we call it Headless Gas, which is a pretty horrible name, but people get it. And really, this is our push into citizen data science work, if you like. So just the way things evolve and the way GAS itself has evolved, it can do really quite complex tasks, and a lot of these tasks are suitable for being automated. So rather than as geoscientists in your companies or universities, consultancies, having to talk to the IT department in your company and programmers and SQL experts, etc., to try and automate something, what we've done is make a version of GAS which can be put into a server environment where you can publish a workflow to Headless Gas sitting in the server environment, and then it sits there, and via the API, as data arrives into one data management system, it can transmit that data into GAS. GAS will know what workflow to run on that data, and then the data can be pulled back out of GAS and put back into the same database or a different database. So it allows you to run really quite complex procedural things in GAS automatically in a server environment. It goes hand in hand with the automated workflows, of course, and the workflows can achieve really quite tremendously complex things, but you'll be able to make a workflow and have that operating, put it in some sort of a central location in your company, and it can be delivering outputs which are immediately available and usable for people elsewhere in the company, even, not even in the same office. So we've done I think if you go to the next slide, Putra, we've done a very first proof of concept. So this is with Nigel and Chris Brand in West Perth at Portable Analytical Services. They've just building now a robotic system, the robot they've called Dave. So it's not me, but there's the other Dave there, the white thing. A robot that's able to load samples into a Tornado M4, which is a micro XRF scanning thing. It's an amazing machine. Actually, it spews out lots of data, as you might imagine, but they're using Headless Gas running on a virtual machine in the office, soon to be parked up in the cloud, which is taking data as the tornado is generating it and applying calculations and actually rock type classifications to it as the data is being generated by the tornado, and then pumping that back into a separate database. But that was our very, very first proof of concept. We had it up and running there literally in an hour or two, but now Portable Analytical Services are helping us fine tune the implementation of that so that it can scale to take up more CPUs, more memory, and then parallelize things as well when to do some heavy duty data processing. So that's pretty exciting. If you've got an application in mind for that and you're keen to try something, then please just ask us about that. It's not by any means a product yet, but we're on the journey to turning it into a separate product. And the next slide, Putra. You can't talk about technology these days without talking about generative AI or large language models. The GAS help file, you probably don't know this because you've probably not done it, but if you take the GAS help file, which is far, far more than a software user guide, as you will know, and printed it out, it's over 1,000 pages long now, and it's become quite a repository of useful information. Now, while you can search the help file, and that's all fine, it's a bit old-fashioned these days. So what we're in the process of doing is extracting all of the information out of the GAS help file into a large language model. And we're going, at some point in the nearest future, we will release GasBot, or GAS GPT, if you want to call it that, where you'll be able to query GAS using natural language queries and just ask it things. And it will, I hope without hallucinating, give you rational answers back around what you can do within GAS. We regard this as just a starting point. So by ingesting the GAS help file, but we have a lot of our own IP internally and things that our own staff have done with honours theses and PhDs and papers and things. We'll probably start to load those in as well, just to turn it into sort of a generic exploration, geochemistry, GasBot help system, if you like, that you can just ask questions of natural language. Again, if you wanted to get involved in that or add some ideas about it, again, I think it would be a sort of a useful thing for the universities, the education sector to get involved in as well. We're all ears. But that's all I wanted to say about those two things. Now I'm going to hand it back to Putra. He's going to actually show you some of these new features live, which is always brave of him.
Yes, that's right. Okay. All right. So let's get started, and let's actually go through the live demo. Right. So this is ioGAS version 8.1.1. So if you have actually started up ioGAS today, you'll know that you get a notification that says there's a new version that's out. So we've actually released a minor update last night containing a fix for the licensing system. So that's why it says 8.1.1 at the top right there. So the fix is for an issue that we found where a license token was unable to be correctly read if you have upgraded from version 8 to version 8.1. So a few of our users have reported this issue. If we release a patch to rectify this. And there's also a workaround to fix it, but we recommend for you to install the patch, which by default is installed on top of the ioGAS 8.1 installation directory. So if you get prompted, if you're already using 8.1, if you get prompted to install that update, do install that update. Okay, so that's all I have to say about that. So let's just run through the demo. Right, so ioGAS 8.1. I'm going to open one of our provided demonstration drill hole file. And the first thing I want to show you is one of our provided workflows. So I'm just going to open you the demo drill hole file. So this is the one that we ship with the program. And if I go to the workflow ribbon right here at the top, you see that in version 8, it was previously called workflow beta. And the reason for that being there's a few things in there that we couldn't quite squeeze in for the 8.0 release, but in 8.1, we've actually fleshed it out a bit more. So it's actually called workflow now. So if you look in the workflow ribbon, you see there's a couple of new icons in here called provided. All right, so it's under the run and the playback pan. But let's go through the playback. Let's go to the run option. And if I look in the provided list, we have two new menus in here. So demo workflows and rock classification. So I mentioned about this a bit during the presentation. So we'll just run through one of these. So this is an example of a demonstration workflow using our drill hole demo data. This is a classification of downhole geochem using PCA, UMAP, and dbScan, and with comparison of results in a cross-tab window. So I'm just going to click on this. And what it will do is it will run through generating the results all in one go. So that's the run button. That's what it does. So it just runs through everything automatically with no interruption, unless you create steps in the workflow where you interrupt the steps in between. And generally, what this workflow does is it generates a couple of things. So it generates a PCA biplot, generates a classification diagram, and generates a UMAP. So the UMAP is a dimension reduction technique that we've added in V8. And this workflow basically looks at comparing the result of applying dbScan on the UMAP output, and then looking at comparing the way that we can looking at comparing this classification against log geology. So what I'm going to do now actually is I'm going to go to the attribute manager, and I'm going to auto attribute by geology, and then I'm going to auto attribute by the classification from this classification diagram. So you have three sets of color. And what I'll do is I will just play with the undo and redo button. So watch as I'm doing this. So this allows me to flicker between three different color schemes. So I'll bring up the legend to show you what we're looking at. So what we're looking at here is just classification from where it plots in the Hallberg diagram. And then when I click undo, we're looking at the colors from the log geology. And this is the 3D attribute map right here. So I can actually rotate it using my mouse button, by my keyboard left and right key. And I'm rotating it along the elevation axis. Right? So that's a 3D attribute map. I'm going to click on undo again to look at the dbScan colors. Right? So this is a nice little way of using the undo and redo button, which of course we've added in V8. Just a way of flicking between the different way that we can color up our data. And of course, we got the cross tab here, which is always useful for highlighting, comparing, between comparison between different text columns in our file. Okay, so that is an example of a provided workflow, and I'm going to show you some of the other workflows later on. So now we're just going to open a different file, and we're going to look at actually a file that Scott Haley provides in one of his training tutorials. And I'm going to show you some of the other tools that we have in 8.1. So the data doctor has a couple of new things in there, which I'll run you through. So I'll just show you this file first. And I don't know if anyone can, or anyone has done this before, but you can actually sort in the data window. So you can see here that this file has a number of below detection limit values. So we'll need to run them through the data doctor, which we'll go through now. So watch as I go through the data doctor. You see that there's a whole bunch of rows in here that has, a bunch of columns in here that has a bunch of negative and null entries. And whereas before in ioGAS, you can replace null with null, but it still keeps them in the data doctor, which sometimes can be confusing. So what we have done is we have actually allowed people to ignore nulls in data doctor. So there's a checkbox in here. You see that it says ignore nulls. So if I click on that on and off, you can see what it does. So this is the behavior as it was in V8. So if you have null values, if you have replaced them with null, it still appears in the dialog, but you can click on that to ignore columns with nulls as an issue, which is technically not an issue, but it's just a flagging thing. But it only highlights basically things like below detection limit or over range values or text values in the numeric column, things like that. So that's one thing that we've added in the data doctor. I'll show you how to run through another provided workflow, and this one is actually inspired by one of Scott Haley's tutorial. So if you go to the workflow ribbon, if you run under the provided ribbon under the playback band, under raw classification, you'll see 3 provided raw classification workflow. So the one at the bottom here, the VMS raw classification. So that's in-house. So we actually have, I think we have Ross Large in the call as well, but we have one of his diagrams in this provided workflow, which is nice to have in here. Then we also have a porphyry copper geochemistry classification workflow inspired by Scott Haley's tutorial. And we have the barcode project workflow, which we showed in the ioGAS demo for the V8 webinars. So we'll just run through the porphyry copper geochem workflow. And apologies in advance if I butcher this workflow, but we'll just run through this slowly. But basically what this is...
So Putra, you're not brave enough to do the VMS one with Ross Large watching.
Yes.
Sorry.
Yep. All right. So basically, this workflow is pretty straightforward. So it has a bunch of guided steps in between. So this is what we call a guided workflow. And a guided workflow usually has a bunch of steps in between that allows you to do things between each steps. So in here, for example, the workflow spits out the probability plot and it tells you to assess the distribution. And we want to check that we don't have censored values more than 70% of the data for each variable. So things like that. So we'll just run through each step. So in this step, we open up a scatter plot matrix or a YX plot of some of our elements that are useful in this workflow. And in this part of the workflow, we generally use the thorium versus scandium plot to generate clusters, and the workflow actually guides you through it, and it tells you what to do. So create color groups in the attribute manager, and you want to create the number of groups that you correspond with the number of clusters that you see. So that's exactly what I'll do. So I'll just do what the workflow says, and then I'll just keep on playing. And it says generally you want to assign samples with high scandium and low thorium to be mafic type rocks, etc., etc. And that's exactly what we're going to do now. So what I'll do, and I'm going to cap off the workflow quite quickly at this point, just to show you that this is the sort of thing that you can do with a guided workflow. And there's a few other examples where people might want to do this, especially one that's commonly used in the industry. So I can generally see about 3 or 4 clusters in here, which is why I created 4 color groups. And our task now is to try to come up with a name as to what we want to call these color groups. So there's a couple of ways that we can do that. And the way that we're going to show you is through the new and refined mineral and rock nodes dialog. So if I click on the mineral rock nodes button, the button is still the same. It's just a dialog that has been revamped. So you can see there's a couple of things in here. So we've reworked the bottom part of this dialog a bit. So we now have a clear all, we have a load and a save. And I'll talk about this in a minute. And then in the minerals tab, you can actually see there's a new button in here to save selected minerals to a new assemblage. So we'll talk through that in a bit. So for now, I just want to reset the state of it. So just to click on the clear all button. So this will turn off visibility for all nodes. And what I want to do is I want to select some rocks that will help me guide my the way that I can name some of these rock types. So I'm gonna try and search for things like andesite. And this is one thing that we've added actually in V8. So you can find nodes that corresponds to andesite, and it highlights the tab and it does it. So, but the cool thing about 8.1 now is that you can hold down the shift key on your keyboard and you can select multiple items. And that's what I did just now. So I'm just going to search for basalt. So I'm going to do the same thing. I'm going to select a whole bunch of basalt using my shift key as well. I'm going to select some from the USGS. And I think I'm going to select some. I'm not going to select anything from the Cox et al. Because these are all major elements, whereas we only have some trace elements here, so they're not going to be able to be plotted. So I think I still need to select some granite as well. And I think I need to select some dacite, although I don't think that they will plot because they're in the Cox et al. So we'll just leave it as that. And what we'll do now is we'll go back to, we'll click OK. And we'll go back here. And if we click on the mineral and rock nodes, we'll see the rock types in here. So this gives me a bit of a guidance as to what we're going to call some of these rock types. So we know that for samples with low thorium and high scandium, we want to call them as mafic. And then something like here, we want to call them as andesite. All right, so that's just a part of that workflow that we can do. I'm going to show you how we can save a selection of mineral assemblage along with the selection of rock assemblage as well. So I'm going to open a classification diagram. So this is by Davies and Whitehead. And I'm going to open up some minerals instead of rocks this time. So I'm going to select, so say, for example, if I'm in the other silica tab, and I'm going to search for muscovite. And that appears in the shit silicates tab, of course. And you can also select from a whole bunch of multiple items from here. And then you can create your own mineral assemblage. From in here, for example, I can select proplitic and click on. So that will select all the minerals under this assemblage. And then I'm also going to turn on those from argillic. So that has populated this list as well. And then effectively, I can use this as a way of editing existing mineral assemblage or creating a new mineral assemblage based on my selection. So I'm just going to call this. So you can choose to either call it the same name as the one in this list. So this is a new drop-down list sort of interface that we've added in a multiple place in ioGAS. But I'm just going to call it ioGAS demo assemblage. And you can actually look at it under this list. And you can actually see it at the bottom right there in italics called ioGAS demo assemblage. So what I can do is I can clear all of my minerals in here later on, and you can actually click them on. So what I'll do now is I'm just going to click on the off button in here for all minerals. So we don't have any minerals selected, and we just select my mineral assemblage that I created and click on, and there you go. So that effectively what this is, it saves it into a file in ioGAS, like a mineral selection file that you can configure as sort of ioGAS if you want, and it's quite an easy file to set up. There's another thing that I want to show you, and that's the save current selection button. So you know that we have already selected a whole bunch of rock nodes in here. So you can save a collection of minerals OSNACA. So this is Carl Brohardt's OSNACA list. If you haven't used it before, you should. It's really informative and useful. And you can also create your own user nodes. And again, if you have any question on how to create your own user nodes, the help file has a really good guide for doing that. But otherwise, let us know and we'll guide you through it. So what we're going to do now is we're going to save this minerals and rock selection as a nodes file. So it's an XML file. And as with any XML file that you've used in the past with ioGAS, so like with diagrams and calculations, you can send an XML file using email to someone else in your company. And effectively, what this allows people to do is, rather than tell them to select this and this minerals and rocks for your project, you can just give them the XML file and they can open it up as they want at any time. So I'm just going to call this, I guess, table selection. Okay, and I'm going to click on clear all. So imagine we're just starting from scratch. We open up a new file, new session, different computer. You can load a selection, and that will just turn on everything all at once automatically, which is quite cool. All right.
Hey,
So
Putra,
what we'll do now? Yes.
I've got a question for you, Putra.
Yeah.
Have we yet put in a system where those customized mineral node file acts like the diagrams and calculations where customers can put it on a central part of their system and gas can see it?
That's a good question. I think we do have the mechanism for that, but even if the so we do support the ability to just put that into the user location, but otherwise they can just copy that file across to each user's configuration directory, and it'll just load it up automatically. So I'm going to show how to record a workflow that remembers how to bring up those mineral and rock nodes. So what we're going to do now is we're going to actually record a workflow. So I'm going to click on the new workflow button, and it's going to close all of my windows. And I'll show you this is a new, this is a revamp of the checkpoint dialog. So you can, if you have multiple checkpoints, you can choose to rename it to an existing checkpoint name, or you can basically populate anything from the name of this under this list. So I'm just going to call it with the default name, which is the date. I'm going to select the variables from this file. And in this workflow, I'm going to run through a couple of things. So I'm going to open up a couple of scatter plots. So I'm going to open up scatter plot of scandium versus titanium. And I'm going to open a bunch of nodes from the IIST tab. So this is a Japanese Geological Survey information. And then I'm going to create a regression analysis. And the regression analysis will produce a number of output columns. So predicted, residual, and opening up a diagram, and attributing outlier. So we do support opening up a regression analysis in a workflow now. So what I will do is I'm going to save this. And I've stopped that. And I'm just going to close it. And I'm going to revert the state of the file. And I'm going to play back that workflow. So you can see that, we didn't have any minerals selected. Well, If you have a different set of minerals or rock selected in the mineral rock node, it will select whatever you have recorded in the workflow recorder, right? So it tells you that the workflow will want to turn on these particular nodes and so on and so forth, and we'll turn them on within this instance of this workflow. So we've generated a couple of extra columns as well and open up this diagram. And the last step is just attributing as outliers from this regression analysis. If you look in select variables dialog, you'll see that it's recorded the action of generating output from the regression analysis. So those are a couple of things that we've added in the regression analysis, in the workflow recorder. So support for a bunch of things in the right-hand side toolbar, like mineral nodes, but also things like regression analysis in the analysis ribbon. All right, so let's move on to another file, and I'll show you another provided workflow. As Sophie said in the chat, yes, it's possible to share node selection files. So thanks for that, Sophie. That my memory failed me for a bit, but it's possible to share node selection files on the server in similar way we do with user diagrams and calcs. So it's there's a configuration file, and if you put it in a server in a shared central location, you can allow people like within your organization to share that file between your users. All right, so this is the same file that we had in the ioGAS 8 webinar, and we've actually provided this workflow in the provided workflow list. So the barcode project workflow. So generally, what this workflow does is it runs through a bunch of columns, and it selects where certain columns. So it's based on a few ratios in the file. So if silica is higher than 58%, and if certain ratios are higher than or between certain values, you assign them to a rock type. And essentially, the resulting output is a bunch of rock classification values. So that's the barcode data. But the reason why I want to show you this file is I want to show you the new renderer tool, right? So I'm just going to remove all of my colors now. So this file has 5,000 rows, so it's not that big, but I'll show you if I plot, for example, titanium and zirconium in this file. And if I select a whole bunch of immobile elements, open it up in a scatterplot matrix, we actually have a new renderer in here that you can access from the file ribbon. That's called the call mode. So at the moment, it's actually displaying it in call mode. So I'm just going to do a couple of showcase where we compare between showing it through default. So this is the default way that it's displayed, and this is the faster mode, which we call the call mode. So essentially, you can see a bit of the difference there. So when you have overlying data points, it only renders, it obfuscates the data. So it only renders the one on top of everything else, but it never obfuscates the outliers. So it keeps the outliers, but it makes the display more efficient. So you can see there's a tooltip in the bottom there that tells you how many % of the data is rendered in view at any given time. So being a 5,000 row data set, you probably couldn't see much of a difference, but it actually does feel a lot faster from my end. So I'm going to just do a couple of simple things in here. So, some of the workflows that people tend to do is they tend to apply this coloring thing on an XY plot. And you can see this is with the call mode on. And if I choose to display with the normal rendering setting, it does feel a bit more sluggish. So if I just go like that, so there's a bit of a lag in the rendering. That's a bit faster if you watch it in the call mode. I'm not certain if you could see the difference just now, but do have a play with this. This is one of the features that we want people's feedback on, and that's why it's still called beta in here. So it works on XY and ternary plot. So what will be good is if you can start up 8.1, open any large data set that you have. So anything above 50,000 rows, something like that. Open it up in a scatter plot and engage this new renderer mode called the CAL renderer mode, which you can access from the file ribbon. So file settings, and turn this on, and just let us know how you go. We'll be really keen to see if it improves the way that you display your data. All right. So last file in our session this morning, and I'm actually going to run you through this and show you the new aliasing exception list. So it is another one of Scott Haley's file. So it has a couple of outputs from spectral mineralogy output. And the thing about ioGAS is that if you press guess alias in this file, you've accidentally alias silica opaline % as silica %, and FEOX wavelength as FEO ppm, which is not what you want, right? So what you want to do is we have this new thing called the aliasing exceptions, which you can access from your, so replace this with your username, app data, roaming, ioGAS user config, and you can add your own aliasing exception list. So I'm just gonna add that column from that file, and I'll show you what it does. So I've added, remember this is the column that was alias, and what I'll do now is I have to restart GAS, and I'll show you what it does when you open that file again. So notice that as I click guess alias, FEOX wavelength is still alias as FEO ppm, and that's because I haven't added this column name to this aliasing exception list. But because I've added silica opaline %, if I click on guess alias, that doesn't get guess as silica %. So that's quite useful, especially because we know that people bring in not just geochem data these days, but they can bring in everything else right into ioGAS. So that should be quite useful. Whereas before in the past, you have to tell us to add to our aliasing exception list, which we control from our backend. But now you can control this configuration yourself, which is quite handy. So a few other things before we wrap up. So if you have used ioGAS since version 8, you know of the search function in here at the top. So say if I want to look at things like, so for example, if I want to look for a certain diagram, so if I want to look at find a box plot, sorry, let's find something like a Halberg diagram. I can just filter it like that using this filter right here at the top. But if I don't engage this filter, it will come up with everything that has the word Halberg in it. But if I engage the filter to enable diagram, does it like that. And if I want to just filter it just on the diagrams and calculations that we provide, I can do that as well. So that's a really handy thing that you can do. And this also works on the basis of tools. So if you don't know where certain things are, so say, for example, if I want to look at where Mahalanobis base distance tool is, if you don't know exactly where they are, you can type that in and select toolbar, and that's what's going to appear in this list. So the filter is quite useful. That's number one. Number two is we have some improvements to the missing data analysis tool. I'm just going to run you through that quickly. So the missing analysis tool, so whereas before you know that this file has 49 assay columns. So whereas before if you want to just select this variables that has assay data across all of these columns, what you can do is you can just do that. Oh, sorry, I got it the other way around. So you can just right click on this item in this list, and it will just select whatever is in the present list right there. And you can also select from the missing list to replace existing variable selection. So rather than going through this list manually one at a time and looking at this and finding, say, cerium, cesium, and going through it one at a time, what you can do now is you can just right-click and do that instead. So that's quite handy. And the last thing that we want to show is the fact that we have moved this query select tool to here in the data ribbon instead of the data icon. So whereas before it was here, so it's a bit hidden. That's why not a lot of people probably know about this. But now we've actually moved it here. So as a reminder, this is what the tool does. So this can allow you to do this sort of thing. So find potassium higher than the median of 2.98%, things like that. So yeah, so that's the last thing that I want to show in this webinar. So that pretty much sums us up. So yeah, I saw that the chats in there has been quite good. So yeah, thanks again, everyone.
Hey, Putra, Chris Ben's got another question there, but Soph will read that. But I just want to say a couple of things about what's coming in the next version of GAS. So the downhole plots in GAS are wildly popular, but we also get that they're hideously ugly. And so the next release, the downhole plots are going to be vastly improved. And I've already seen an alpha version of it, and they look great. And the other thing, people have been asking this for, I don't know, how long's GAS been around? 18 years. For us to put factor analysis in, and I've resisted for a long time, merely because there's no unique solution to a factor analysis. If you do a principal components analysis, there is only one correct mathematical solution to that problem. There's only one answer, whereas a factor analysis, there is not. It regards that there is user input and decisions about how many components to drop off and then to re-rotate the component axes and rotate them according to some criterion that you impose on the data. Nevertheless, it can be useful, and so people have been asking all that time, so we will put that into the next version of GAS. But with one caveat, if you use it and get silly results, then the problem's between the seat and the screen, not GAS. So it comes to the caveat.
And that's a good point about the downhole plot revamp, Dave. So that's one thing that we like to engage our users on. So we'll be in touch with our customer base over the next few months just to get people's feedback on what we have come up with so far and see how further we can take it, essentially. But thanks again, everyone.
We do listen. If you've got requests, ideas, questions, then at the usual message is please send them in.
And no such thing as a silly request.
No, correct.
Yeah. So the email address to address it to is either through our website or iogas@imdexlimited.com. So if you have any questions, just put it there. One of us in the chat here will be monitoring it.
Thanks, Putra.
Thank you. Thanks, everyone. Have a good morning, good afternoon, or evening, wherever you are.